equals y, so it doesn't matter which one because it's the same. So I've done that. Now I have x equals negative 3. I could choose either one of these equations and substitute negative 3 in for x, and they give me the y value. It doesn't matter which one you use. Okay. I'm going to use the second one, and I'm going to say y equals 2x minus 5. Y equals, bringing that down, 2. Instead of writing x here, I'm substituting in negative 3 and put minus 5. Bring it down. So y equals, the product of 2 and negative 3 is negative 6. Bring down, subtract 5. Negative 6 minus 5 is negative 11. Therefore, y equals negative 11. So my point of intersection, my solution to the system, which is my point of intersection, is negative 3, comma, negative 11. So far, we had two that gave us a variable statement. Okay. So moving on to example 3. Example 3, we have here, 3x plus 4y equals negative 3. Then I have here x plus 2y equals negative 1. Okay, I have two equations that's in standard form, meaning I have to either take the first equation or the second equation, and I'm going to have to either solve for the variable x or the variable y. It doesn't matter which one. Okay, in this case, I'm choosing 2 because the x has a coefficient of 1. That means less step. I can get x by itself by subtracting 2y, and that's it. So first, I'm going to take equation 2, and I have to solve for either x or y. In this case, I'm solving for x. So I'm going to say x plus 2y equals negative 1. Notice I'm not writing down the step. I'm verbally saying the step, meaning you need to pause and write the step down if need to. So I'm going to subtract 2y from both sides because I need to isolate this variable. Subtract 2y from both sides. These are like additive inverse, cancel, bring down my x equals. These are not like terms, so I write them beside each other. I write negative 2y minus 1. So now I have the second equation by itself. So I have two systems that is similar to the example 1. Here we had y already isolated. So now I got x isolated, and I have a equation that's in standard form. Okay. So now I'm going to go to do the exact same thing I did with example 1. So now I'm going to take number 1, because I used number 2 to solve for x. So I'm going to take the other equation, which is number 1. I'm going to write it down, 3x plus 4y equals negative 3. Now, I'm going to substitute in negative 2y minus 1 for x. So 3 times negative 2y minus 1. And I'm going to close that and bring down my plus 4y equals negative 3. Just substituting in for x. After I do that, I have to get rid of the parentheses using the distributive property. So I'm going to say 3 times negative 2y, give me negative 6y. 3 times negative 1 is minus 1. Bring down my plus 4y, bring down my equals and my negative 3. Next, I'm going to combine like terms. I have a y term here and a y term here. So negative 6 plus 4y. Negative 6y plus 4y minus 1 equals negative 3. I rearranged the equation so that my like terms could be next to each other. Negative 6 plus 4 is negative 2. The variable is y minus 1 equals negative 3. Now I have a two-step equation that I need to solve for y. So I'm going to get rid of the negative 1 first. I'm going to add 1 to both sides. Additive inverse cancel. Bring down my negative 2y equals negative 3 plus 1. That would be negative 2. Y isn't isolated yet. Therefore, I'm going to divide each side by negative 2, the coefficient of y. Negative 2 divided by negative 2 is a positive 1. So I have 1y equals negative 2 divided by negative 2 is a positive 1. So I know that my value for y is 1. This is a hint that I'm going to get a variable statement. Well, one solution, intersection, a point of intersection. So next, what I'm going to do, I'm going to take this value of y, and I'm going to substitute it back into the other equation, which is 2, the second equation. So I'm going to take that second equation. Now, guys, you probably say, well, could we, since we already solved for x here, could I use that? Absolutely, because that is still equation 2. So I'm going to take x equals negative 2y minus 1. And I'm going to substitute in 1 for y. So I'm going to say x equals negative 2. Y is 1, so I'm going to replace the y with 1. Put minus 1. So x equals, use the order of operation, negative 2 times 1 is negative 2, minus 1. X equals negative 2 minus 1, which is negative 3. So now my point of intersection, I know it's going to be negative 3, comma, that's my x is negative 3, it goes first, comma, the y value, which is 1. So my solution is negative 3, 1. And I know you guys probably say, oh my gosh, Missy, man, you're really going fast. It's a video. Pause it, okay? That was example 3. So next, let's do example 4. Example 4, I have here negative 5x plus 4y equals 20. Then I have 10x minus 8y equals negative 40. Okay. I have two equations that's in standard form. Okay. Yes, I labeled it 1 and 2. Same process. So in this case, both is in standard form, meaning I have to either solve for x or y. It doesn't matter which one. This time, I'm going to choose 1. I'm going to choose 1, and I'm going to solve for, let's solve for y. I'm going to solve for y. Okay? And you may want to write that down because I'm verbally saying it instead of writing it. So I'm going to write negative 5x plus 4y equals 20. I'm going to solve for y so that I can substitute into the other equation to find the value of x. So now I'm going to add 5x to both sides because I'm trying to isolate the y. So add 5x. This cancel, that goes to 0. Bring down my 4y equals 5x plus 20. Do I have y by itself? No. So I'm going to divide each term in the equation by the coefficient 4. This 4 divided by 4 cancel out. Leave me with 1y equals 5/4 x plus 20 over 4. Really? No, I'm not going to write 20 over 4. 20 over 4 simplified to, there you go, 5. Very good. Okay. So next, I solve for y. So now I'm going to take the second equation and I'm going to substitute in for y so that I can have one variable in the equation. So I have here 10x minus 8y equals negative 40. So I'm going to write 10x minus 8 in parentheses. Instead of putting in y, I'm going to substitute in 5/4 x plus 5. Then I have here equals negative 40. Okay. Now let's go. We're going to distribute to get rid of the parentheses. So I have here 10x. This is a negative 8 that I'm distributing. So I got negative 8 times 5/4. Okay. So negative 8 times 5/4, you can go to the side and do that. So I have negative 8, it's real over 1, since we're doing fractions, 5/4. Okay, guys, you really know you can use the calculator if you're in class. Or negative 8 times 5 is negative 40 over 4.